Hi, I'm Bob. Welcome back to our solutions to the problems in the textbook Microeconomics Theory and Applications with Calculus, the 5th edition. In today's section, we will find answers to the following 3 questions in Chapter 14 about the Cournot model. Let's get started. Here is exercise 3.7. It is about the market power of the firms. A monopoly is the only firm in the market with the highest market power, and it can set a higher price than duopoly firms, other things being equal. As the number of firms in the market increases, each firm's market power falls, and the equilibrium price drops. We can use math to show it. Suppose n identical firms face a market demand PQ and have a marginal cost MC. We can write firm 1's revenue R1, which equals P times Q1. Its marginal revenue is the derivative of revenue with respect to output. We can rearrange the terms and define epsilon, the price elasticity of demand in the market. In equilibrium, each identical firm's output should be the same. We can simplify the expression of MR1. We know that in equilibrium, marginal revenue equals marginal cost. Then we have an equation that relates price to marginal cost, the number of firms, and the market demand elasticity. We can further write the market power measure, the lunar index, as minus 1 divided by n times epsilon. We find that as the number of firms increases, the firm's market power falls. In other words, fewer firms in the market, higher prices they can set above their marginal costs. Other things equal. That is why the monopoly firm sets the highest price. The duopoly firms set the second highest price, and the price falls as more firms are in the market. Let's solve exercise 3.8. In 2005, the prices for 36 prescription painkillers shot up as much as 15% after one of them was yanked from the market due to fears that it caused heart problems. Can this product's asset be the cause of the price increases if the prices reflect a Nash-Cournot equilibrium? Explain. We have an equation that relates the Nash-Cournot equilibrium price to the number of firms in the market. In previous exercises, we have derived a formula for the equilibrium price. The partial derivative of P star with respect to n is negative. As the number of firms n decreases, the equilibrium price increases. Therefore, the asset of the product can be the cause of the price increase. Let's address exercise 3.9. Consider the Cournot model with n firms. The inverse linear market demand function is P equals A minus B times Q. Each of the n identical firms has the same cost function. In terms of n, what is each firm's Nash equilibrium output and profit and equilibrium price? As n gets very large, does each firm's equilibrium profit approach 0? Why? We can tackle the problem in two steps. In the first step, we will use the best response functions to find the Nash-Cournot equilibrium quantity and price. In the second step, we will examine how the number of firms in the market changes each firm's output and profit, and the market equilibrium price. From the firm's cost function, we derive the marginal cost function, which equals A plus B times the firm's output Q. In the Nash-Cournot model, each firm operates like a monopoly, facing its residual demand. That is, it maximizes its profit at the outcome level Q star that satisfies marginal revenue equals marginal cost, which is called a first-order condition. We can write the firm's revenue function and its marginal revenue function. The first-order condition leads to the firm's best response function, equation 1. You can express Q1 in terms of other firms' outputs, if you like. But we don't need to do that. By symmetry, each identical firm's output in the Nash-Cournot equilibrium should be the same. So the best response function can be written as an equation with only one unknown variable, Q star. We can solve for Q star. Substituting Q star into the market inverse demand function gives the equilibrium price P star. Next, we figure out how the parameter n changes the market price and each firm's output. As the number of firms in the market n approaches infinity, each firm's output approaches 0 because the denominator approaches infinity. As the number of firms approaches infinity, the equilibrium price approaches the marginal cost. We can divide P star into two terms. The first term approaches 0. For the second term, we focus on its denominator. There are two parts. The first part approaches 0 as n goes to infinity. The second part approaches b as n goes to infinity. So, the second term approaches A. The equilibrium price P star is the sum of the two terms, and therefore it approaches A, where A is the firm's marginal cost when output goes to 0 as the number of firms goes to infinity. Finally, the firm's equilibrium profit pi star is the product of P star and Q star. As the number of firms goes to infinity, each firm's equilibrium profit goes to 0 because Q star approaches 0 and P star approaches a constant. It is true that as n gets very large, each firm's equilibrium profit approaches 0. Thank you for watching this video and subscribing to my YouTube channel. See you next time.